So welcome everybody at DevOpsCon and to my talk, Highway to Heaven, Building Microservices in the Cloud. I'm Deger. I'm Chief Architect at AutoScout24. I'm with AutoScout for over 6 years now. Started as a software engineer, team lead architect, and now chief architect. And I'm going to talk about a project which I was there from the beginning. So what is AutoScout? Who does not know what AutoScout24 is? Okay, it's like Auto Trader wherever you're coming from. So it's a used car listings business. AutoScout is the largest online car marketplace Europe-wide. And we have about 2.4 million listings of used cars and bikes on our platform. So there's a platform to buy and sell used cars. So we're at the DevOps conference. I still wanted to know a little bit about my audience. Who is doing continuous integration? Hey, this is everybody, or at least almost everybody. Great. Who is doing continuous delivery? Okay, about half the room. Who is doing infrastructure as code? Okay, great. Who is in the cloud? Yes, and who plans to moving to the cloud? Okay, so for those who didn't see the room, about half of you are doing continuous delivery and half of you are already in the cloud. Who is also doing microservices? Great, so you should know everything I'm talking about. Yes, nevertheless, we try to make this a fun exercise. So this is what AutoScout looks like in our cash stack. This is called cash stack because this is still making most of our money. So we used to run a Windows ASP.NET stack using an Oracle database, and everything is virtualized using VMware. We have about 2,000 of those virtualized servers running in 2 data centers for disaster recovery. And the whole setup is used for meantime between failure. So expensive hardware with redundant power supplies to actually make this a highly available platform. And the platform supported the growth of AutoScout for many years. So conceptually, this is a working platform. Nevertheless, it's rigid in the data center and optimized for meantime between failure. This is how our organizational setup looked like. We had a development department and an operations department, and the development department was driven by the wish for changes, and the operations department was driven by the need for stability. And when software engineers wanted to release a new version of their software, they are more or less released by throwing a package over the virtual wall between those 2 departments. And you could feel this wall. There's always friction between those departments. The operations team set up a ticket systems to funnel the changes and protect themselves from the changes. And the software engineers actually didn't know how the software were run, how many servers it was running on. And if they introduced a performance degradation, for example, the operations department just bought more servers or spun up more virtual machines. So quite a disconnect and a friction and a handover between those 2 departments. Who knows similar setups like this? Yes. And this isn't the only handover we had. There's additional handovers between software engineering and QA, and between product management and software engineering. And every one of those handovers causes friction and you lose time. So, and this is how operation felt. Engineers were just going home, even when everything was on fire. Then within AutoScout, a group of people wanted to change something. They wanted to move to the cloud, to microservices, everything. But there was resistance within AutoScout. Not everybody liked that idea. We didn't want to end up at the enterprise IT adoption line we wanted to be with the rest of the world, or at least somewhere in there. But there was resistance against this kind of changes. We wanted to be like Netflix. Netflix is in the cloud, is fast, and doing all those experiments. But people said, hey, we are not like Netflix. This is a streaming portal. We are selling cars on our platform. Different business, doesn't compare. And actually, we have already a private cloud. If you want something that you can't have on our private cloud, we will build it for you just like in the public cloud. Okay, so we were stuck. Then in end of 2013, Scout24, our holding, was sold to private investors. A new CEO came on board in the beginning of 2014, and things changed. He started to ask questions like, are you ready for the future? Do you attract talent? And then we realized, okay, .NET, Windows is not the greatest thing in the internet business you can run off. You get good .NET developers in Munich, but typically from insurances and banks, so we needed to teach them how the internet works. They didn't bring in that much new ideas. And when looking at other companies that we look out for, Netflix or those kind of things, nobody's on .NET, at least none of the big players. And what does a 21st century company actually look like? I already mentioned Netflix, but there are some companies in there which are mentioned all the time when we look out for how actually new companies should look like. And when looking at those companies, we also realized that nowadays innovation does not happen anymore at the traditional enterprise suppliers like IBM, Oracle, or Microsoft. Innovation now happens at companies like LinkedIn that have created Kafka. So this also changed, and this is why we also wanted to change and move into an ecosystem that's similar to those, what those companies are using. These are some of the traits those companies have and which we also wanted to have. So we realized we are good, but we are not great. There's something missing. We need to change things. When we decided to actually reboot everything, to change a lot of things at the same time. We called this Project Tatsu to incorporate all those changes, and this is what we set out to actually change. As I already mentioned, moving from .NET, Windows to JVM Linux. Getting rid of Windows was very important for us because we wanted to automate many things, which is not that easy with Windows. So moving to Linux is a good choice. And JVM and .NET is for us a good migration path because, as I mentioned already, many of those companies are using the JVM, at least in 2014. Now decisions might look different, but 2 years ago this was a good bet. We also wanted to transform our monolith to microservices, and we want to move out of the data center to AWS, and we wanted to get rid of our dev and ops silos and go over to a true collaboration culture. And we didn't only want to do a technical migration, meaning just rewrite everything in a new language on a new platform, but we also wanted to involve product people to actually build a new version of AutoScout. When looking at all of those changes, this is a risky endeavor. This is quite something we need to approach there. But we also felt we couldn't leave any of those changes out. If we would leave one of those changes out, we wouldn't end up where we actually wanted to be. So we really decided to do everything at the same time. Okay, why microservices? What reasons are there to use microservices nowadays? Shout at me. Scalability?
Shutting off the tendency to build monolith.
Okay. So do microservices to not build monoliths. Okay, yeah. Okay. Yes. Okay, so you know already a lot about microservices. This is my personal take at why we are doing microservices. The most important thing in there for me is speed. We want to be faster. Development cycles and also to have fast local decisions. So a team supporting one microservice needs to only talk with themselves, not actually discuss it with the whole company who is part of the monolith, collective code ownership and all of those things. Of course, those services are independent deployable, which also allows them to be fast. And fast local decisions also means that those decisions could involve technology diversity. Autonomous teams also support the fast local decisions. And to have autonomous teams, they need to be loosely coupled, also on a technical side, but also on an organizational side. And you not only can scale the application better, but you can also scale the organization. My personal experience is that collective code ownership in a monolith with about 20 engineers stops working. Above that, it's everybody's trampling on the code of each other, and you don't actually know what's happening when you change something. And of course, you also have strong boundaries. This is similar to the notion, don't build a monolith by doing microservices. A funny notion, but in essence, it means you should modularize your monolith anyway. But when you modularize your monolith, it's hard to enforce the boundaries of the modules. By going to microservices, you have a process boundary which forces you to actually respect those boundaries. Does this make sense? Okay. Of course, there is a downside to microservices. If you have a poorly structured monolith, having a poorly structured microservice architecture is then even more problematic. Refactoring a monolith or cleaning up a mess in a monolith is easier than cleaning up a mess in microservices. So be aware of that. Two short definitions of microservices: loosely coupled, service-oriented, bounded context. Microservice, all small, autonomous, work together. Hopefully you know Sam Newman and Adrian Cockcroft, especially Adrian Cockcroft is one of those guys. You should watch what he's doing. He's now at AWS, but he was CTO at Netflix before that, with a small battery venture in between. When reasoning about microservices and what other companies are doing, we looked at Amazon and Twitter, and these are the so-called Death Star diagrams. And these are dependency graphs of those companies. If you look at Amazon in 2008, I imagine this looks way more complicated now. And also Twitter has quite a complicated graph of dependencies there. So these are heavily distributed systems. And we at AutoScout, we didn't have a lot of experiences with distributed systems. So we felt when going the microservices route, we should do a step in between, which is called self-contained systems. Meaning, there might not be as micro as the other microservices, but in essence, you have one of those vertical slices of your application, which is a self-contained system, which is owned by a team, built by a team, and run by a team, and is representing one business capability within your whole set of systems or applications. Another trait of those self-contained systems is that they contain their own UI. So typically a request hitting a self-contained system should be served by the self-contained system itself without a fan out to many of those other services like you have seen in the diagrams before, which also means that they are typically integrated at the UI level. So this was a sane step in between in our transition phase, especially because we already had split up our monoliths in the data center into swim lanes, we called them. They were still coupled through a shared database. Those swim lanes were mainly introduced to get advantages by making them independently deployable, so improving on the continuous delivery side without a true decoupling as they are shared. And the migration strategy was more or less take those vertical slices and rebuild them on AWS using the JVM and as self-contained systems or microservices. When we started our journey in end of November 2014, we started with one team. In that first team, we had former software engineers and former operations guy in one team with some external help. And this team has gone through the preparation phase, and they started more or less from scratch. So they started with an AWS account, starting building their first service. They were very tightly aligned. This was, they knew how they wanted to build their first system. And the idea was to then ramp up the number of teams by splitting the team and adding more team members and introduce more of AutoScout to the new way of working. And when we were at about 4 teams, we realized that the original alignment between those team members was not longer existing. So we started to formalize our principles and our way of working. We introduced our Scout IT principles with strategic goals, which are aligned with business, and architectural principles supporting those strategic goals and design and delivery principles. And the idea behind this principles was that we as teams actually came up with those principles, we shaped them, we gather feedback around them and evolve them, and we then use them as a tool for decision making in meetings. If somebody is deviating or there's a decision to be made, we always look whether we're actually following our principles. It's also a very useful tool to realize the gap between what you want to do and what is actually happening in reality. So you can always check whether this works. Be aware, these are our principles, and the journey and coming up with those principles is actually for the culture and for working like that the important part. So don't just copy them and use them as your principles. That might work, but the idea is actually coming up with them and having the discussion around it. I won't go into detail into many of those things. Some I will mention later in the talk. Just the most important strategic goal: reduce time to market. This is in alignment with why we are also doing microservices. Being fast, making local decisions, and actually get the feedback loops right. This is the most important piece in there. So why do we want to be fast? From Lean Startup, we learned that the build, measure, and learn cycle is very important. You need to get your products in front of real users to actually validate and measure that they are working. And the faster you can iterate through this feedback loop, the better your product will be. And this is a differentiator nowadays between successful companies and not so successful companies, how fast you actually can iterate. When talking about microservices, you also need to be aware of Conway's law. In essence, it states the organizational communication structure is reflected in your architecture. And this also is true for the reverse. So we wanted to have microservices. Therefore, we also need to have an organizational setup that is in alignment with those microservices. Meaning, we wanted to have autonomous teams that are organized around the business capability. So we wanted to build self-contained systems which represent the business capability. Therefore, we need to, and those should be loosely coupled and autonomous. Therefore, we also need teams that are autonomous and organized around those business capabilities to be not in conflict with Conway's law. Those two need to be aligned, otherwise you will cause a lot of friction and you will know when Conway's law is biting you. Those autonomous teams, we also call them self-organizing cells. They are empowered, and this also means that you now should think in products and not in projects. And the whole idea of this setup is that those teams now can make fast local decisions within the team. So the organizational setup is optimizing for that and is not optimizing for cross-team organization. So you need to do something else to get that right. And as I already mentioned, this allows you to actually scale your organization. a good example of a company that's working like that and from where a lot of those ideas originate is Amazon. So if you want to know more about that, there are some talks how Amazon actually does that. And Amazon and AWS scale quite well and still are fast companies that execute well and have a lot of innovation ideas in there. So this is where many of those ideas come from. And of course, we also wanted to have the collaboration culture so that those autonomous teams are actually cross-functional. So DevOps is not a team, not a role, but having former operations guy and software engineers actually work in the same team and not have those department silos with all the defects that emit from those department silos, having software that is hard to operate or infrastructure that then actually nobody uses. This also means collaboration, that we try to use tools which helps us with collaboration. For example, GitHub or Slack. Another very important thing for us is you build it, you run it. So those autonomous teams that build a service are actually responsible for shaping, building, running, maintaining the service. So they're responsible for the whole life cycle of their product. This means they have freedom as in the fast local decision, but they also have the responsibility to take care of their service. So in the former dev and ops silo world, an operations guy was standing up in the middle of the night when he was called from his pager when one of the services broke down. In the new world, the team or one of the team members who actually knows how to fix the service is called. So the team members are actually on call, even in Germany, where you need to have an addition to your contract to actually be allowed to do that. And when a service breaks in the middle of the night, the team has to stand up, which, due to the feedback loop, because nobody wants to stand up in the middle of the night, they try to build services which don't break. So the outcome of this is not that the people who are on call now have to stand up every time and fix those services, but the outcome is that they are now building robust and resilient services because they don't want to do that. And the you build it, you run it meme also includes the product lifecycle, so learning from the real customers and improving the product in the meantime. So not only operational aspects. To make this transition more explicit to us, we are also now calling us engineers. So we're not talking about software developers or operation guys anymore. We are just all engineers to get rid of those previous notions. When we then talk about a cross-functional team and the full-stack developer, we of course don't believe that one engineer can work on the whole stack with total excellence from backend to the frontend. So every one of those has a T-shape or a pie shape or you call it. But important is that the whole team has overlaps so that the team can support what is actually needed. This is one of our dashboards from one of our teams. It's half a year old, but has not drastically changed. And this is, for me, the beauty of this cultural change, to see how the team actually took responsibility of their service. So nobody told them to build this dashboard. They built it out of their own, and they built it to actually keep their service up and running. So putting all of those metrics and utilization and latencies on there, they did to support the service. So they're measuring the latency, and they actually learned that it's important to look at the higher percentiles and not at average latencies or stuff like that. There are also, as we're on AWS, they can collect the cost that their service occurred over the last day. So they're aware of the cost, the operational cost of their service, and feel responsible for that. They also know the Google page speed of their web page, how fast they are. We use Opsgenie for paging. They have their alerts on there, their open alerts. So all of those things is required for the team, and they did it in themselves. So this, I find this this is remarkable. And what's also on there is monitoring is the new testing. Meaning, of course, we do testing, but in a microservices world, when a lot of those services are brought into production at the same time and every team is continuously delivering, especially integration tests do not make that much sense anymore. You need to verify that your services are actually well behaving and integrating in production. Because if you only verify during your delivery that everything is working, you actually don't know when another team is releasing their service, what's happening there. So you need to invest more in testing, in monitoring, excuse me. What's missing there, and which hopefully the teams will introduce also, I hope that they will take care also for business KPIs, meaning that in our case, how many leads we are generating or something like that. A business metric is also in there, because all those operational things are fine, but what's really mattered is that the customers outside can use our services and actually can do what they want. And if those numbers go down, then this is a very, very good insight. This is a meme I like, and this happened. Follow the trail, meaning other are calling it now the paved road. Nevertheless, the same idea. It means microservices allow technology diversity, but you don't want to end up with every team building everything in a completely different language. But we also are not enforcing anything. But what happened in reality, teams just follow the convenience offering previous teams or earlier decisions that were already made. So we have for example, a service template for our services. This is our normal stack is a Scala Play application, CloudFormation template, monitoring, everything is in there. So teams just use that template to bring a new service into production. So it's easy for them to stay with Scala Play and the default solutions. So, but they are not forced to. If they want to do a Golang application and do stuff differently, they can do that. But then they need to maintain and support what they're actually building there. So they are not longer following the trail, but they are now in the bushes. It's a little bit more difficult, and their product needs to support that decision, but they are free to. Up until now, almost all of those teams just stayed on the trail and are not deviating despite having the freedom. So this kind of convenience offering works very well. And also it really matters to automate a lot of things and build templates for them. I already mentioned that we have those autonomous teams, those cells, and their communication is optimized for the communication within the team. But of course, you need also alignment across the teams. And we came up with guilds following the Spotify model. And we have those guilds are self-organized common interest expert groups. We have a macro architecture guild, an infrastructure guild, a Frontend guild, and a QA guild. They're meeting about once a week, most of them, and they are discussing those cross-cutting topics. Every team needs to the infrastructure, but to actually share the knowledge or to make decisions how to go forward, they meet in those guilds to fill the gap of the cross-communication, cross-team communication. What's also on that slide is beware of the Mandelbrot teams. I came up with that word because of the fractals and how things could look similar when you zoom in. This is just a warning. If you go down the route, we had previously the dev and ops silos. And sometimes when you look at a team, it also looks like that. So the engineers, the software developers are sitting on the right side, and the ops guys are sitting on the left side, and the ops guys are doing ops stuff, and the software engineering are building the service, and they actually don't talk that much to each other. And be aware if this appears, this is violating the cross-functional team, and having more pairing and actually working on tasks together helped to getting rid of this Mandelbrot teams. When doing microservices or doing any of those newer fancy things, whatever comes your way, continuous delivery, and half the room is already doing it, and that's great, is, I feel, the most important practice in our industry you need to adopt if you're not already doing it. I've already asked you who is doing continuous delivery, so we can skip that. Jess Humble, who co-authored the continuous delivery book, recently is giving talks about how he extracted data from a DevOps survey and doing a lot of science on top of it. The talk was called Sciencing the Crap Out of DevOps. And using statistical models, he more or less could prove that continuous delivery as a practice has a positive impact on IT performance, a negative impact on failure rate or change failures, development pain goes down, and so those numbers on there is more or less how strongly those are correlated. So there is now science proving that continuous delivery is good for IT performance, and despite that it's not intuitive, but the more often you release, the fewer errors you get. So if you need to convince somebody that this is a good idea, if you have not yet, you could use that argument. So now how does continuous delivery look like in the simplest form as we are doing it in the data center? Application code for one service is on GitHub. Then you have your commit stage, the software is built, unit tests are run, everything needed to verify that the software is actually working, and then you build an artifact and store it somewhere. And then in the delivery phase, you take that artifact and, in our case, roll it out on a predefined set of servers and update the software, and hopefully without interruption the new version of the software is running in production. What's wrong with that picture? Or what's wrong, what could be improved? So why are we doing continuous delivery? We want to have a reliable, repeatable, and traceable way to get changes into production. So everything is automated, so it's reliable and repeatable, and it's traceable. Every change is coming from the source code repository. But back in the data center with our operations department, those servers were created via a ticket. There were patches introduced from the operations department, software updates, configuration changes. So a lot of the things that happen in production are actually not traceable or repeatable. Only code is delivered in that way. So when going to AWS and having more capabilities around infrastructure automation, we changed that approach. And now we have a repository where we have the code for the application and the infrastructure specification in the same repository. In the commit stage, we still build the artifact, but we also have the infrastructure declaration as an artifact using CloudFormation and some Ruby scripts. And when we deliver into production, we first apply the infrastructure changes to the production environment for that service using CloudFormation, auto-scaling groups. The EC2 instances are then restarted in a rolling update. And when the new instances are starting, they're fetching the artifacts from from our artifact repository, simply S3, and are starting the application on a newly created EC2 instance. So now also the infrastructure changes are traceable, reliable, and repeatable. Infrastructure as code. And we actually know, and this is then also an advantage of using AWS, where everything is accessible via an API, that we now know all changes are coming through the delivery pipeline, which allows us, using CloudTrail, a global in-API logging service. So every API call for infrastructure changes is logged in CloudTrail. We can now monitor and alert on production changes which are not coming through the delivery pipeline. So if an engineer goes in there and changes a DynamoDB setting or does anything in there, an alert is created for the whole team that somebody is fiddling with the production environment. So in this way, we can make sure that all changes in production are actually following that pattern. There is no outside interference with that environment. So Keith Morris was with us in the beginning of the project, and he wrote the book on it. No, not only on us, but so the infrastructure as code book is the whole idea that infrastructure is now not something which is living separate. And of course, there's also the notion of cattle, not pets. The servers are restarted. Of course, you don't give them any names anymore. And you also now can have, using those immutable servers, you also don't have configuration drift on them. And you can also monitor on the age of those instances. So for example, to make sure that you have the latest security patches which are not applied to running instances, only to the base MI, which are used to start new services, you can then infer that if no instance is older than 2 weeks, that you have rather recent security patches on there. So also something you can then alert on. When talking about releases and continuous integration, who of you is doing feature branches and continuous integration? Okay. There's news. It's controversy, but continuous integration and feature branches actually don't work together. So if you want to do truly continuous integration, you should do trunk-based or master-based development and use a concept called feature toggles to actually enable rolling out a feature. So this means separating the code deployment from the feature release. Who's using feature toggles? Okay. So this is, Martin Fowler has written a very good blog post, or I believe this was a ghostwriter or a colleague of him, but talking about feature toggles and how they can be used, what different kind of feature toggles are there. So if you haven't heard about them, please read this up. This is a rather simple concept that helps you a lot getting those releases and continuous integration done properly. And he's also talking about how you could use the toggling concept also for other things, so that you don't you shouldn't confuse those concepts with one and the same thing. So release toggles are for the release phase. Those should be short-lived, like feature branches. Then you could have experiment and ops toggles. Ops toggles, for example, in case of AutoScout, we have an ops toggle. When some ad is ill-behaving, we have a toggle in there to actually disable the advertisement on the page. This is a toggle that stays in there, versus a release toggle, which is only during feature development, or versus an experiment toggle, which you could use for A/B testing. And this helps really a lot getting things into production fast and decouple those topics. We then thought about how we actually have those continuous delivery pipelines for many of those services. But if you have microservices, there's always one of those pipelines running, and how we actually verify that the different versions of those microservices can actually work together. In that example, when you look at the blue service, who is in the staging environment in version 2, and he is verifying in the staging environment that the integration with version 5 of the yellow service is working, and then the blue service goes into production. What's happening? Yes? Yes. So he verified with version 5, everything is fine. He goes into production, but the yellow service is also just releasing. So there's another version running in production of the yellow service. This led us to the idea that actually having a dedicated staging environment where we verify the integration between those services conceptually could not even work, because you're verifying against another version of the services you integrate with than what you actually end up having in production. In our data center, we used to have a staging environment. We spend a lot of time getting this as production-like as possible, verifying that the configuration drift between production and the staging environment wasn't too big. We had a lot of broken builds in the staging environment, not due to broken software, but due to configuration drifts, databases not being similar, stuff like that. So we had a lot of pain with the staging environment. And nevertheless, we still got outages in production because the load was different, the data was different, user behavior in production is different than in staging. So you don't find all of those errors, which on AWS, we are no longer having a staging environment. So we go from our dev environment, which we of course have, directly into production. This does not mean that we are stupid, we are bold, but not stupid. There are things we adopted to actually make this still working. So for example, consumer-driven contracts to mitigate the problem of which version you're actually meeting in production, as the consumer is writing a test for the service he's integrating with, and you can run the appropriate consumer-driven contract to actually verify that it's working, using canary releases where you're just holding out the service to a portion of the traffic to verify that it's working before you enable the new version for the whole load, using a technique called shadow traffic, where we actually duplicating the traffic in different ways to actually make the new service be aware of the whole load, but without using the response that's actually returned. And as I already mentioned, using something like semantic monitoring, where we are constantly exercising user journey tests, only a few very important ones, that core functionalities across our pages are actually working. In the end, those concepts are easier and simpler to maintain than the previous staging environment, and we still have the same or even more confidence to go into production with our code than before. So this really helped. I already mentioned that the self-contained systems should be integrated via the UI. Let's briefly look into our front-end integration pattern, which still should adhere to our principles, having loosely coupled autonomous teams, and the result should still be the rendered page highly optimized on a page speed perspective. On AWS, we use CloudFront, so all the traffic goes through CloudFront. As we are still in a hybrid setup, so this is a journey, we are not finished there yet. The requests for services for which we have not built yet something on AWS, the requests just go back to the data center, to the existing services there. If we have already built a service for it, it's going to an ELB and a jigsaw, which is more or less our composition layer, which is Nginx using Nginx or mod page speed, and using SSI includes to compose a page out of those different self-contained system services. For example, the header and the footer is coming from a different service and they're composed together. Or if you think for AutoScout, we have the list page where you can actually search and then you see a list of listings. Those listings are coming from a different service than the service who's rendering who's returning the search result. So they are composed together. Using SSI includes, and the trick is in there to have those fragments as self-contained as possible. So we didn't want to build an asset pipeline to deliver the assets, and the fragments itself should contain their own CSS and their own JavaScript. But when you look at the result, the page brings its own CSS and its own JavaScript, and the fragments bring their own CSS and JavaScript. This is totally nightmare for page speed. This is not how a page should look like. And the trick is then just at runtime to use mod page speed from Google, which then realigns and combines the assets so that the result is then page speed optimized. And so we get, there's a trade-off in there, but mostly we get the best of both worlds. We can have autonomous teams building self-contained fragments and compose them together and get proper page speed as a result. reInvent was last week with a keynote also from Werner Vogels. I believe many of you have watched it. Werner Vogels, CTO of Amazon, so he's also behind the Death Star diagram, and a remarkable quote: "Everything fails all the time." For a public cloud vendor, yes, but if you run at that scale, failure is totally normal. There's all the time does something break. So in our data center setup, everything was optimized for mean time between failure. So please don't break your servers. And now the notion is everything fails all the time. So this leads us to resilience or chaos engineering. And that's the formula for availability. What's availability? It's the mean time to failure divided by the mean time to failure plus the mean time to recovery, which is in essence the total time. And in the data center setup, to get a high availability, we try to get the mean time to failure up there. So, and on AWS, this is out of our control. This is not something we control. To get the mean time to recovery as low as possible also leads to a high availability. And this is how we now roll, getting stuff up and running despite everything is breaking. So you probably know the Simian Army from Netflix, especially the Chaos Monkey, which is also running at AutoScout. So during the work hours, when we could react if something really would go wrong, those instances of our service are randomly terminated. The team just gets a Slack notice. The following instance was now terminated. This is for all our services, with very few exceptions. This is running all the time. And so this gives us the capability to actually make sure that our services are resilient together with other patterns around resilience, circuit breaker, timeouts, and bulkheads. So this is the end of the slides. Thank you very much. And if you have questions, I'm free to answer them. Okay, so this is a very good question. So I believe you need to have management support, upper level management support. In our case, we tried to change things in the beginning, as I told you, from the bottom up. Did not work. You can't work through the resistance. That I believe those structures are in there for quite some time, having departments, having managers in there, so that you will have a lot of resistance and fear that this is going the wrong way. So management support, I believe, is really important. When we started our first team, the team members in there were eager to participate in that one. So getting out of the whole crew a few people who actually are eager to do that is easy. And in the operations department was the most resistance. So many of those changes were driven by development and some ops, and there were especially VMware administrator and those guys there. I believe they still believe that we are doing the wrong thing there. But having the first ops guys in the first team really helped because they liked the new way of working. So this was an experiment also, and this was encouraging to the others. When they came back to their old teams for a chat or for lunch, they told them the stories, what they have learned and the new experiences. And over time, the mood changed. So those who were afraid of the change now wanted to be part of the thing because this actually works. And if you tell the story right, if you're a good operation guy, and then you can add to your CV, you know AWS, this is a big plus nowadays. If somebody gets that training for free, but still some convincing needs to be placed, I'm not sure that we over time keep all of the operation guys, especially when turning off the data center and the load balancer specialist doesn't have anything to do. But up until now, nobody has gone because of the change. And the short answer is start with an experiment and get the success and get the people in the mood that this is actually a good thing, and they will tag along those who want to come along. Those that don't want to come along, have an honest conversation with them, and maybe if they find a place where they can be after that. So in essence, you get to learn AWS, infrastructure as code, a lot of, this is a whole thing of new stuff to learn now with Docker, which is also appearing, which you hopefully have talked about during those conferences a lot. And if you're not taking up those opportunities, then we want to attract talents. But this also means if you don't want to be in there, you don't want to be in there. Yes?
How much shared infrastructure do you have between microservices?
So the core idea is to have as few as possible because sharing introduces coupling. So an interesting story, when the first team started their first dashboard, as we have seen, we will run dashing, which is a Ruby application on a dedicated instance. And the second team just added another dashboard to the same server. And Ruby, and there is a static variable in there, and in essence they ended up with shared state, meaning that the number of requests per second on one of their tiles, both teams shared. Meaning that every 5 or 2 minutes it changed between the request for service A back to the request for service B. And it took them 2 days to figure that out, flipping from 50 requests to 2,000 requests and back and forth. So they shared a dashboard and introduced an error which, if it would be in production, would be catastrophic. So now every team has its own dashboard service. It's not optimal from a resource utilization perspective, but it's decoupled. So shared services, we have a shared logging infrastructure because this is a macro architecture concern where we say we want to have all the logs to be there for administration purposes. It needs to be there. We have a shared monitoring solution, but this is as a service, so it's not really there. And one thing we also shared by not knowing it better, which we learned now, is our delivery pipeline. So we are using one Go CD server for all teams, which puts a lot of load on the thing and also introduces coupling. So we also want to move this away to have more localized delivery tools for teams, so they're not sharing one of those instances. So it's getting fewer and fewer. And what about data stores? So in a microservices world, each microservice should have its own data store. So every team that's operating a microservices is also responsible for a data store, nor shared data store, with an exception, the data lake, which is, I have perhaps a picture in there, I have dropped it. Ooh. No, I've deleted it. But so when you do microservices, you don't have a shared database anymore, which means things like data warehouse, business intelligence gets more complicated because you can't extract everything from one database. So you need to forward the events and the behavioral and the usage data from those services into a central. We have an event streaming pipeline where everything goes then into S3 and optionally into Elasticsearch, so that you can do your data warehousing, analytics, and machine learning on top of that data. So this is shared, but only in a way that we are collecting the data there and everybody can use it. But so to reduce the coupling there also.
If I can ask one more. So if several teams need a MongoDB database, each team needs to find out what that scale with clustering and all that stuff?
So MongoDB would, they need to get past me to run MongoDB. If we pick a different, I have an opinion there, but just to run with the example, yes, every team would need to do that. But so we have currently what's happening, it's more or less around Elasticsearch, where it's a similar notion. So, of course, our search runs on Elasticsearch, but other teams also have need for searching capabilities. So the first team has built their infrastructure themselves because there was nobody to help them. They have set up Elasticsearch. By the way, the managed Elasticsearch from AWS is not very helpful currently in its way. We would have preferred to use it as a service. So, but they are setting this thing up. And the second team learned from that experience. And now we have around 5 of those Elasticsearch clusters running. And we have an Elasticsearch guild now to share experiences. And this is one of the things where now a platform team will harvest this shared this experience and build perhaps an appliance model out of it or something like that to make it easier, or a service template to help them operate it, but they will not operate it for them. So it's still in helping and building a platform and hopefully getting to a managed service world. The core idea for us is currently to work in a similar model like AWS works. So we try to use AWS services first, because the whole idea of going to the cloud is not to do the undifferentiated heavy lifting of running MongoDB, but just to insert coins to run DynamoDB. But if a service offering is not available, for example, we wanted to use Kafka, there's nothing which exactly replicates Kafka on AWS, so we need to set up our own Kafka cluster. And these topics are, whenever it works for us, it should be built by the team who needs it, and only later be stolen or taken from them by the platform who's then making a commodity offering out of that. So you have then the AWS service offerings, and then you have the Scout offerings, which are an opt-in model for those teams, which they can then use, but still mostly on an appliance model or a multi-tenant model where you're not actually sharing data or data stores. So we wouldn't set up a central MongoDB. Okay, one last question.
Yeah, you mentioned the follow the trail.
Yeah.
And you showed them this template. And I'm asking you, how do you do the same and the thing with the responsibility with the templates? You said most of them in your teams use these templates, but who's then responsible?
So we have a lucky team who, by winning the lottery more or less, or not running away fast enough, who got the responsibility for the service template. So so in the beginning, up until 6 teams, we didn't have any shared service team. So there was no platform underlying those teams. So all those services that are shared, the logging I already mentioned, the UI composition is also by nature a shared service, were operated by one of those teams, and typically the teams who needed it first, or those teams who were the early teams, and then that stayed with them. Now we have a platform, and some of those topics might wander down to the platform, but not necessarily. So if we now a team would start a Golang service, I believe they would then later own the Golang service template, which also makes sense. But you can't push your responsibility away. There's nobody is there to push your stuff. Hopefully it stays like that, but the notion that you can't push your things away. If somebody comes around and says, okay, I will help you, like AWS always asks, what feedback do you have on those services? How are you working with the services? What could we improve? What next services would you wish from us? And if enough customers say that, they will build a service like that. And this is a model, but I can't tell AWS to build a hosted MongoDB for me. If they do it, I might use it. No, I might not. But if they build it, I could use it, but I can't force them. And I believe this is an important trait, and also from a cultural and organizational perspective, you need to be responsible. A guy from Netflix once said, "I'm not responsible for your freedom." So this needs to be okay. One last question, then. So I counted it today. We have more teams, but teams that are now in this Tatsu AWS world, at least partly 15 teams. Mm-hmm. Varying from small teams 3, which is typically then too small, where we are then just hiring, by the way, and to bigger teams. One shared service team is currently, I believe, 10 or something, but this is then the upper end. The rule of thumb for team size, also Jeff Bezos, the 2 pizza team size. So American Pizza, a team should be so big or not bigger than what you can feed with 2 American pizzas. 8, 9 would be a good thing. Lower boundary typically for you, especially you build it, you run it, means if you're 3 people in a team, this is a quite heavy rotation. So 4 to 5 would be a lower boundary. Okay, thank you very much.